Now we've already introduced you to the theoretical probability. Now we're going to move on to experimental probability and the examples. So on this slide, this is the definition. A definition for an experimental probability is often used to estimate theoretical probability and to make predictions. So what you want to do is figure out the number of trials is in the denominator, and then in the numerator is the number of times the event actually occurred. So here are some examples of the experimental probability. So here's a spinner, and it has 4 numbers on it, 1, 2, 3, and 4, and has the colors red and yellow. So let's pretend we went out and spun the spinner, and it landed 6 times on the number 1, 11 times on the number 2, 19 times on the number 3, and 14 times on the number 4. And we want to find out what is the experimental probability of landing on a 4. So what we have to do is figure out how many times we actually went out and spun the spinner. So we have to total up this column. So we did 50 trials. We spun it 50 times, and that was our occurrences. Now we need to total up how many times it actually occurred. There was 14 of them. So the probability of a 4 is how many times it occurred, 14, out of the total trials. So you have a 14 out of 50, which we like to reduce it down to 7 out of 25, or 0.28, or 28%. Here's another example. Find the experimental probability of that same spinner, but now we want to find out what is the probability that you will get a number greater than 2. So we want to total up. Again, it's the same trial, and we had 50. Now I need to figure out how many of these are greater than 2. Well, we can't pick 2, so we have to pick 3 and 4. So we're going to total up 19 and 14. So 19 plus 14 is 33. So the probability of getting a number greater than 2, we had 33 times that it happened out of 50 trials, or 0.66, or 66%. All right, now let's move on to a deck of cards. So we're playing a deck of cards, and we recorded our suits and the number of times we got that suit. Remember, a suit is your hearts, diamonds, clubs, and spades. And we are replacing. That means you put the card back into the deck. So for hearts, we got 5 hearts. 9 times we got diamonds. 7 times we got clubs. And 5 times we got spades. And we wanted to find out what is the probability that we got a diamond. So again, we have to total up these 4 numbers, which is 26. So the probability of a diamond, the total trials is 26 trials, so 26 times we got a card. And how many times did it actually occur that we got a diamond? 9 out of 26. All right, here is one more of these. Remember how we've taught you about complements? Well, we're going to do an example of complements. So we have this same experimental. We have the 5, 9, 7, and 5 spades. So remember, this is our total of 26 trials. We want to find out what is the probability of not getting a club. So we say, what is the probability of getting a club? So we say, here's our 7 out of 26. Now we're going to use the complement. So you're going to go 1 minus the probability of a complement, or of the complement, or of the club. So 1 minus 7 out of 26. I'm going to change that 26 to 26 out of 26 minus 7 out of 26 equals 19 out of 26. Now, yes, you could go back and just add up all the ones that are not clubs. But sometimes using a complement, when you have a very big group of trials, the complement 1 minus the probability of the club would be faster.